Hello everyone, and welcome to Biopedia. Although it can't be seen from space, the Great Wall of China is certainly one of the most iconic structures in the world today. It was first made out of earth ramparts and was initially constructed from 215 to 210 BCE in the reign of Qi Shi Huangdi, the so-called first emperor who unified China under the Qin dynasty in 221 BCE. The wall, added to over the course of some 2,000 years, is 5,500 kilometres long and is one of the largest construction projects ever undertaken. Although it was originally designed to repel nomadic attacks from the north, it also served to create another division. Specifically, it appears to be dividing species from themselves. 6 plant species were studied on both sides of the Yuyongguan Great Wall, a section of the wall built during the Ming dynasty in 1368, which is about 60 or 70 miles north of Beijing. These plants were a mix of wind-pollinated and insect-pollinated plants from 5 or more different families. As a control, 5 either identical species or close relatives were studied on a mountain path which did not contain a stretch of the Great Wall. This leads me on to say that the difficulty with this kind of work apparently comes in finding a suitable control site. Most of the wall was constructed on mountaintops or cliffs, which means that there could be gradients in conditions even without the wall's presence. For example, one side of a mountain might get drastically more sunlight than another. These natural differences have to be taken into account when considering if genetic differentiation is due to the impact of the wall or not, so a suitable control site has to be found. Accordingly, a mountaintop near the Yuyongguan section of the wall was found, which had roughly equivalent conditions, although it wasn't possible to find a site where the distances between subpopulations were the same. So, genetic differences were studied at the actual study site itself and the control site. What was found was that at least 71.1% of the genetic variation of populations was within subpopulations on either side of the wall, while a far smaller proportion was distributed between subpopulations. Analysis showed that, although there were also significant differences between subpopulations in the control location, the sites of the Great Wall showed significantly more differentiation between subpopulations on either side of the wall. What this means is that populations on either side of the wall are significantly more differentiated than subpopulations in control sites without the wall. Except for about 1 to 4 individuals, Great Wall sites were found to have individuals of a species clustered together in populations. For instance, 3 of the plants studied had only 1 or 2 individuals from one subpopulation present in the population on the other side of the wall. This shows that gene flow is in fact being impeded by the Great Wall as there is not more mixing. The results show that some gene flow is still occurring, but it is unclear whether that is due to wind action, animals, or indeed humans. The variance between subpopulations without the wall was about half that present at the wall, indicating that the Yuyongguan Great Wall at least is acting as a physical barrier to gene flow. Such physical barriers could be the reason for allopatric speciation occurring, speciation in which different populations become physically isolated from one another and eventually go their separate evolutionary ways to become new species. On that note, next week we'll discuss another form of speciation which doesn't require spatial isolation at all, namely sympatric speciation. As always, thank you for listening. I understand there was a lot of the word population and subpopulation in today's episode, but that's kind of unavoidable. Regardless, I hope you understood all of that. Feel free to get in touch with the show at biopediapodcast@gmail.com for any questions, comments, or topic suggestions for future episodes. Until next time, have a great week, everyone.